Today we're going to talk about a simple string problem. Given two strings, we want to determine if we can transform the first string into the second by swapping two of its characters. Here's a quick example. We have two strings and we swap two of the characters in the first string so that the two strings match. Let's walk through how we can arrive at a solution by looking at some examples. We can immediately answer false for any inputs that don't have the same length of strings. We can also answer false to any inputs whose strings have two different multisets of characters. There's a few different ways to figure out if this is the case. The fastest is to count the appearances of each character in each of the strings and compare the two resulting lists of frequencies. A slower method would be to sort both of the strings and check if they become equal. If we pass this check, then we know that one string is actually a permutation of the other. After eliminating these simple cases, the first thing we might notice after looking at a few examples is that in order for the answer to be true, we can only have at most two mismatched characters. When we say mismatch, we refer to the indices where the characters differ between the two strings, shown here by these lines. For any inputs where we have more than two mismatches, it is guaranteed that a single swap won't fix the differences. Inputs with exactly one mismatch would actually fail the earlier test comparing character appearance frequencies, since if there is exactly one mismatch, we can determine that the two strings are actually not permutations of each other. For inputs with exactly two mismatches, we just check to see if we can fix both by swapping the mismatched characters in the first string. Furthermore, since we know that the two strings are permutations of each other, we don't even need to check if the two mismatches fix each other. As long as we have exactly two mismatches, the answer is true. There's only one more case, when we have zero mismatches to begin with. In other words, the input strings are equal. In this case, we still need to perform a swap, so we want to perform our swap without changing the string. This is possible only when some character appears more than once, allowing us to swap identical characters. The first implementation of this is fairly straightforward. Start by handling the cases that instantly give us a false return value, the size differences and the character frequencies. If both of those pass, then count the mismatches. Since we know that the two strings are permutations of each other, we don't actually need to record what the mismatches are, only the number of them. If there's exactly two mismatches, return true. If there's exactly zero mismatches, check for a duplicate character. If any other number of mismatches is found, or if there's no duplicate character, return false. And that's it for our initial implementation. We can improve the performance of this implementation a fair bit by changing it to a one-pass algorithm. In fact, doing so is fast enough to beat the performance of 100% of the other submissions in the judge system, which, just to note, has some inconsistent timing. At the same time, we can also simplify our cases at the end to get much shorter code.